All right, let's go with it here. So we are homework session, I guess. Yeah. So let's go. It says use the definition of, this is 2.3, 3.2, sorry, 63. And we are going to use the definition of derivative to find the derivative of this guy. Ooh, how fun. Okay, so let's go with it here. So let's do the derivative formula itself here. Ta-da. So this would be this right here. It would be 1 over the square root of x plus h minus the square root of h over h. So that would be the first things first, because we're plugging in. So off to the side if we need to here. If we need to, we'll plug in, that's what we need to plug in. So we have this little extra h on the side. Cool. Okay, so whenever you see a complex fraction, you know what you're going to do. Oh, and I forgot, sorry, limit as h goes to 0. There we go. That kind of helps out.
Do you want to get them like on the denominator to the top so we can do the x or the h up?
Absolutely. So limit as h goes to 0. So to get common denominators for the top, we're going to have to just multiply both of them together. So on the first one, it's going to be the square root of x gets multiplied to the square root of x plus h. So that means on top, we have an extra square root of x. On the next one, we have the same exact denominator. So this time, we have multiplied in a square root of x plus h. You guys talk to me if you're okay.
Yeah. So when we're doing these problems like on a test or something, do we have to write limit as h goes to 0 every time, or okay?
Yeah, because you're doing a problem.
Okay.
Otherwise, it's just a difference quotient and not a derivative definition. Okay, with that said, limit as h goes to 0. Let's see what we have here. Let's say I have a square root of x, square root of x plus h. On top, I have a square root of h minus the square root of x plus h. That's what I'm left with right here over h. And the trick, right? There's always a little trick. First of all, let's do this here. Let's make this into a multiplication problem so we don't have all that stuff hanging over us here. So we're going to multiply that. So this will be a limit as h goes to 0. This will be this right here.
We put together the bottom denominator square root of x times square root of x h, like, is that something we can do with like our radicals? Like square root of x squared plus hx.
Say again.
Can we, this is probably stupid, but can we multiply the x square root of x across into the square root of x, like square root of x squared plus hx?
Oh, yeah, you can do that because they both have the same index. They're both square roots.
Yeah.
But I think it gets more complicated as opposed to keeping them further apart and separate here. So limit as h goes to 0 of, and here's what we have, and here's our little problem. We're good. So I'm going to have this right here. Let me write it out. So this little h right over here, now it's kind of sitting right here. We have a square root of, we have square root of x, and we have the square root of x plus h. So our issue is not the h that's inside the square root on the denominator. Our issue is that h sort of sitting right there having fun in our denominator by itself. And so we have something called conjugates. Do you guys remember conjugates?
X square root of x plus.
Absolutely, we can multiply by that, both top and bottom. And we'll see what happens.
I feel like these things, if you mess up on one step early on, you're toast.
Yeah, my colleague at the college, he says that calculus is just algebra on steroids. That's
It kind of is.
Okay, so I'm thinking, let's do the top here. This top, they're conjugates. We multiplied it for a certain purpose right here, right? We multiplied it so that the square roots will go away completely, right? The middle terms will cancel. So we have ourselves square root of x times square root of x would just be x. Middle terms are gone, so we have ourselves then x plus h, because the in terms will give us that. Are we okay
Why
with
is
that?
it plus h and not minus h? Oh, wait, not minus h.
And then we have h square root of x, square root of x plus h. And on top, we finally get where we have the x's are going to cancel to that. Go ahead, Kate, you talk to me here.
Where did the bottom part go when we multiplied it?
The bottom part still the same here. The top, what happened here is that this guy gave me the x,
Yeah.
and then we don't need to do the middles because the middles will cancel themselves out. So you don't need to do FOIL.
Okay, yeah, I got the top part.
Okay.
The bottom part though, since we multiplied the bottom.
Oh, yes,
by
yes, yes. Sorry,
x.
sorry. You are right here. This is going to be the square root of x plus the square root of x plus h. Sorry, totally lost it there.
Wait, wouldn't that be?
Okay, and then this one's gonna, the x's are gonna cancel themselves out as you plug in the, distribute the negative here. So now I have a negative h on top, h on the bottom, and I know what's gonna happen there now.
Wait, why do we? Oh. This is-
X's are gone now.
What's on the top? Did you just?
Uh,
You
the
crossed out
h, yeah, the h is gone.
Now I just have square root of x times square root of x plus h times square root of x plus square root of x plus h.
Uh-huh. Let's see, it's almost. Okay, this guy here, which is okay, and then we got this all stuff, so. Plugging in a 0 now into that. This would be square root of x, this would be the square root of x, square root of x plus the square root of x. How many? That's too many. Okay, let me just check here real quick here. The square root of x, bring it to the top, that'd be negative 1/2. So negative 1/2. That should be the square root and third power. So that should be what we have here. Yeah, that's true. So I just gotta take the derivative here. So these guys, that gives me a negative, a 2x right here, right?
Yeah, 2x square root of x.
So almost done here. So I have a negative on top. I have a square root of x times another square root of x times 2 square root of x. And eventually I get a negative 2 square root of x to the third power. So you can write it like this. Or you can write it as that right there. We could either one of those work. Okay, Kate, are we good there with that one? That was the tough one of them all.
I just need copy that. I took the, or I just did the conjugate thing when I did it before. But I got the wrong answer.
Hmm.
Exactly sure.
I can see real quickly here.
No, I think I just messed up something when I was flipping because I was kind of not working out every single step. But
No, you.
I think that I kind of didn't do it the smartest way because I did the conjugate like that instead of simplifying to get common denominators first.
I think you
What
had
did
to
I-
have the simplification down first, yeah.
Yeah.
Wait, is it still limit? Oh wait, no, we got rid of the H's.
Yeah,
So
so then we put 0 for H's. Real good.
Okay. And remind me why we can't do that earlier on.
Because you have, sure. Because right here, you have still two functions that are totally separate from each other. You want to do it right here, because now you have a function, and now you have to multiply by its conjugate to get rid of stuff. Because you have two square roots, or you have a binomial setup. That's the whole issue there. You have one term subtracting another term. Okay, good there now. Another one.
I don't know any of those problems actually are.
67. Here, you can use my computer too.
No, it's not.
67. So basically the graph.
It says graph its derivative, right? If we, yeah, this is a tough one.
Always funky to graph.
Well, okay, I didn't think I was confused until I looked at their answer because, yeah.
Okay, yeah, and I will say it is,
I get mixed up about negative and positive slope because, like, if the instantaneous slope is negative at a point, it doesn't mean that the derivative graph is going down. It means that it's underneath. It's like underneath
at the
the
point, yeah.
x-axis.
Okay.
It drives me crazy.
So
let's go for it.
said, I started out by writing, it's horizontal tangents.
Absolutely, yeah. So you
Okay.
notice that this has a slope of 0 you run across.
Yeah, so 0
that-
and 3, I
Uh-huh,
said.
uh-huh.
3, yeah.
Yeah, and it looks like it's approaching 0 on this side. So I have this as a 0. And then I,
Should I?
negative 3, yeah, is 0. So the slopes become dots. And maybe that's a good way to say it here.
Okay, so I started with that and then I wrote, wait, I don't know why I wrote that part. So, okay, essentially what I drew at the beginning was, something that looked like, you can kind of, it's on this one, you can kind of see what I drew first is I went down, up at the 0 and then down and up. When it was supposed to be up and then down, and I only knew it was up and down by checking my work, but I don't know why.
Sure, yeah, let's take a look. That'll be an easy one to look at. So if you look at this here, remember, you're thinking about slopes, right? So you're talking about slopes here. As you go through this one, you're looking at a slope right here. Does that look like a positive slope or a negative slope? That's the issue here, right there.
Well, negative if it's under the dot. Wait,
No, you're looking at the line, the tangent lines that are slicing this right here.
Okay, so that's positive.
It's positive, right? It's a slight positive slope, and then right here, right at that dot right there, notice it's this right here.
Still positive.
And notice the curvature. The curvature starts off like this, right? And when it hits this part right here, the curvature starts slowing down as it's getting to the 0, right? So you have a positive slope that's increasing, right? Once it hits that little dot, it starts now decreasing, right? And it goes back to 0.
Okay.
So that means here's we have our maximum slope. And notice it's positive. It's just, notice right here, it's still a positive slope.
Yeah.
And then it hits 0 here. So in this case, what happens, this is our maximum point. No, I don't know what the slope is. Maybe it's 1, right?
I think it was, it was, it was at 1, yeah.
So then we
I
have,
don't need to look at it.
that point happening here. So it's a positive slope and it hits a maximum point right here. So
Okay, so
then,
how would I, so when I'm like doing these problems, how would I take note of that? Say like,
Mhm.
what did you call it? A horizontal?
Let's see, first of all, you're gonna look for tangent lines, right?
Okay, so I got
And you
the
look for horizontal tangent lines.
horizontal tangents, I
Uh-huh.
got that part. And then I wrote, oh, I don't even know. Okay. Wait, I didn't do that. Okay, so then I wrote at from negative infinity to 0, I don't know what I was thinking. This was a while ago. Okay.
Okay.
I don't know if this makes any sense, but I wrote in parentheses negative infinity comma 0, and then f prime of x is greater than 0, like this. And I don't know where that might be.
I don't know where that came
I
from.
don't know.
That's 67, right?
Yeah.
Let's go this way here. I think what you're trying to say, maybe in the negative right here, from here, from -3 to 0,
Yeah.
the slope should be positive. It
Okay,
has to be greater than 0.
that's what I meant. From negative infinity, I guess I don't know if that was right,
Uh-huh.
to 0. It was.
Yeah, I would say
Greater-
-3. Yeah, -3, because the graph is
That's
not
what the graph
defined.
goes to.
Yeah.
Okay, so.
And then you notice that afterwards, notice the slope now, after 0, now the slope becomes like this.
Then
Right.
it goes.
Now you have a
after
negative slope, right? It's a slope downward.
Okay, okay, so maybe that's. what I was trying
So
to
in
say.
this case, I think, yeah, I just, instead of infinity, put 3 and you'll
Okay.
be fine.
Sounds good.
So in this case, now you got a slope that's less than 0 during this interval now.
How did we, so it was going. How do we know it goes up and down from -3 to 0?
You just have to see if this makes sense. If you just put a ruler on here, right? You notice that you have a downward slope,
Yeah.
right? So you know you have a negative slope at this point. So now you look at the curvature. So downward, down slope, you're decreasing. You're going down each
Yeah.
time, right?
Uh-huh.
And then it plateaus again here.
Yeah.
And so as you look at the curvature, almost like have a little ruler that's balancing on that little,
Mhm.
right? And you notice like, whoa, it's going down now.
Yeah.
And it looks like the steepest downward it's going to go is right here.
Okay.
Notice it, right?
Oh.
Because then
okay.
afterwards, it's almost like maybe like a ruler on it with like a little small ball that's in the ruler is kind of just rolling along.
Okay.
And then it's still negative because the ruler is still facing down all this time, right? But then
Uh-huh.
right at the end, the ruler now seems like it's going to go flat again.
So would that also be a good thing to know? Because I think for me it's really helpful to know like the steps. So would it be, so first horizontal tangents, I took note of those, and then I noticed like the range, I guess, from when it's going up and when it's going down, and then also note when it's steepest. Okay.
Yeah,
Okay, so-
and then
and that's
also direction for sure. Which
Yeah.
direction? Is the ruler facing up or down?
Okay.
And so at this point, here's your maximum point, so down here somewhere. That's the maximum that goes. This is just slightly sloped down, slightly sloped down, slightly sloped down. So you know your dots are kind of getting this way right here
Yeah.
until it hits here.
Okay.
And then it's flattening out, flattening out, flattening out, but it's still a negative slope. So flattening out means it's climbing closer to 0. The dots are climbing closer to 0.
Okay. That makes way more sense. Okay.
My cousin, he had a calculus professor, and she said, I have a number of students, maybe 10% of the class, that at the end of calculus, all of a sudden it just clicks.
Oh yeah. Well, I
This
get
is
the
part of
ruler
it.
part. I forgot about like the point and like where it goes, but I forgot about the how to make it know whether it's going up or down on finding the derivative, because I get the first one.
Gotcha. Okay. Uh-huh. Cool.
Okay,
All right. Are we good there?
yeah.
Okay, let's handle maybe one more here before we go.
So you want to do one of yours?
You can ask me.
How about this here? And give me a list of all the homework questions, and I could do a video on them as well.
Okay,
So
I'm
that's no
not
problem.
really sure what all of mine are questions.
Okay.
Actually, I know that 307 from 206 is a definite question, I think. Some of them I just got wrong, and I think if I work through it.
Uh-huh.
maybe-
How about this? Work through them like tonight or whatever. And if you have questions, then just email them. Just say, and you'd have to mention which section it's from because the numbers are continuous for the whole
Oh,
entire
yeah,
chapter.
that's right.
So just say 37, 312, 324,
Okay.
368, and I'll look at them and put things together. If not, then I'll just prep them for Monday's class for sure. So when we come in, here guys, here's the answers to these.
One
Okay.
question I had super quick was from 151. Just, I don't think that problem in particular will be a problem, but it says.
Sorry, that's mine.
Okay, because it says determine the time intervals for when the object is slowing down and speeding up. I was able to find velocity and acceleration easily, but I couldn't remember how to interpret that. And then Sadie says maybe their answer is wrong for that.
Ooh,
I
okay.
think the
I'll
answer
definitely.
for part B of 151 is giving the wrong information. It's right information, but it's not answering the question. It's answering another question I think they've asked in different sections. I maybe check that, but that's what.
Yeah, let me actually check that one then.
Okay,
For sure,
sounds
yeah.
good.
So 151B and 307,
Yeah.
at least the initial list,
Yeah. What?
at least the initial list. And then we go from there.
Oh.
No, you emailed me the rest of the list, but at least I
Okay.
have 307 and
Yes,
151.
yes, yeah.
Okay, so let me stop here because Ms. Berry has to get her class already.